right, let's take a look at some more proofs. Now, this first one, number 3, it's really like already halfway done. I'd say really more than halfway done for you, because they really put together the proof. We just need to fill in the blanks now. All right. So we were told, we were given that PQ and RS were equal. Okay, I see that they marked that for me nicely in the picture. Thank you. And the first line of my proof is PQ is equal to RS. Well, how do I know that? Well, it's given to you, literally given to you. All right, now the next step they did, they said PQ plus QR equals RS plus QR. Now, at first glance, this almost kind of looks like the segment addition postulate, right? Like little segment plus little segment. But then they've got two things over here. So this isn't quite the segment addition postulate, but what I want to just bring your attention to is, notice here we got PQ, there's still PQ. Here's RS, here's RS. So they're really manipulating the first statement. And notice, what did they do to statement number 1? They added segment QR to both sides. So mathematically, they added the same amount, the same geometric thing, to both sides of the equation. So they really used the addition property of equality. So here's an instance where we don't see where they're adding a number to both sides, but they're adding a geometric thing to both sides, a segment to both sides. Okay, so that's where it gets a little bit different. Now, statement 3, we know the reason is the segment addition postulate. Ooh, okay, so now look it down at statement 4, because there's kind of two segment addition postulates going on here, right? And so we need to know which one we really need to talk about in 3. So in 4, they said RS plus QR makes QS. So they're kind of focusing on the right side up here, right? So the only other place we could really use the segment addition postulate would be over here on the left side to say that PQ plus QR all together is PR. So there's statement number 3. We can do segment PQ plus segment QR makes segment, nope, wrong one, PR. All right. And so then it almost kind of seems like magically they get to the end here. And it's almost kind of like, what? What did they do? How did they do that? And so we kind of need to backtrack just a little bit here. Just a little bit backtrack. So notice we have PR, but where was the last time we even talked about PR? Well, that was up here. Here, let me grab a different color since I've already used that color. There we go. There's PR. Now, where, notice we need QS, but this doesn't say QS. But PQ plus QR, what is that equivalent to? PQ plus QR is the same as RS. Oh my gosh, there's just like so many dominoes starting to fall here. Let me get a different color. Let's get that color. There we go. So PR is the same as PQ to QR. PQ plus QR, there's the same thing I'm seeing there, is the same as RS plus QR. Well, there's RS plus QR. What is it equivalent to? QS. So I got to be honest with you here. The book really did some big jumps here, and I don't like how many big jumps they did all in one shot, but really they've got this PR connected to this PQ plus QR, which is the same as that PQ plus QR, which is equivalent to this RS plus QR, which is the same as this RS plus QR, which leads us to QS. So I got to be honest with you. They did basically like an extended version of the transitive property of equality. They basically used it twice. So what they did, and I'll put this in simpler terms here, they said basically if A equals B and B equals C and C equals D, then A equals D. So we had that connection and another connection to bring it all together. They did that same thing. They did PQ and the QR, they did the RS and QR, so they did kind of like that B and that C part right there, if that makes any sense. So I wasn't crazy about this book problem, uh, but in the end, I think you can extend it out just a little bit there to see that they really use the transitive property twice. I probably would have done it as two separate steps, personally. Okay. All right, the other problem, an actual proof that we're going to have to write out. Nothing that is already halfway done for us. So let's take our given. I tell you what, I'm not going to be cheap and lazy. I'm actually going to write it out. But I'm going to drop the congruent sign there. I'll just say they're equal. And I know they're equal because they're given. Let's go ahead and mark that in our picture because they didn't mark it for us. Crazy book people. Angle GFH, so this angle here, is congruent to angle GHF, this angle down here. And they're asking us to prove that angles EFG, so there's EFG hanging out right there, right? EFG, that obtuse looking angle, and angle GHF, that those two angles are supplementary. Okay, well, right now I cannot make that conclusion. There's no real relationship between angles EFG and GHF. So I'm going to have to explore a little bit here and try to find something else in this picture that is geometrically true. And so what else can we say is true in this problem? And the first thing I start to see here is that these two angles are adjacent to each other. Maybe they have some special kind of property with each other. And these are a linear pair, right? And really this is the straight angle postulate at play. And so the straight angle postulate tells us that any number of angles on a straight angle or a straight line have to add up to be 180. And so we can go ahead and state that angle EFG plus angle GFH equal 180 degrees. I'll draw my arrows in here. You don't have to draw the arrows, but I like to draw them just to have them in there. Straight angle postulate. Now, keep in mind, we're trying to show some angles are supplementary. We now have introduced this idea that there are angles that add up to be 180. I feel like we're on the right path here, right? But it's not EFG and GFH, it's EFG and GHF. Man, if only we knew that angle GFH was somehow equal to angle GH. Oh my gosh, it's in the given. It's in the given. So we're going to make this substitution. So we're going to keep angle EFG. And we're going to substitute out the GFH for angle GHF equals 180 by the substitution property of equality. Now, some people might go, boom, we're done. We were asked to prove that those two angles are supplementary. We just showed they added up to equal 180. And I would say you are almost done. You are not fully done. You are going to get points off if you leave it as this. When they say prove the angles are supplementary, that better be the last line of your proof. And right now, that is not the last line of our proof. Now, again, you're going to think this is kind of a little baby step here, but what does it mean for two angles to add up to equal 180 degrees? Well, we get to introduce a vocabulary word. Instead of taking a vocabulary word, which is usually in the given, and then defining it mathematically, this is kind of the opposite effect, right? We see the definition at play here. Two angles that add up to be 180. We can introduce a word. So angle EFG and angle GHF are dun, da, 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 supplementary. And how do we know they're supplementary? Well, we saw that they added up to equal 180. But what reason are we going to give here? Is we're still using the definition of supplementary, except we're basically using it in a backwards way, right? We saw the definition in play. We now just applied the word, and we're saying, well, here's the word. That's how we knew. All right. So hopefully were a little bit easier, maybe a little bit nicer. Again, that number 3 was a little bit of a pickle there at the end. I wouldn't give you anything that kind of crazy on a quiz or test, so don't worry about that one in particular. All right, that's all for that one.